Okay, pre-cal, in this video we are still in Unit 7, Topic 3, and we are continuing with solving trigonometric equations. Okay, so I'm going to start here with example 4. We're told to solve each of the following equations and write the answers in radians. Okay, and again, I have put my unit circle here for convenience, so I don't have to keep scrolling back and forth. All right, so when we're looking at this equation here, there are a couple of things I want you to notice. The first thing is we're writing all of the answers for 4, 5, 6, and 7 in radians. So that's the first thing I need you to recognize. The next thing I need you to recognize is the fact that for this equation, we are going to have to algebraically manipulate it because I do not have all of my trig terms on one side of the equation. So I'm going to have to manipulate it algebraically before I can refer to the unit circle. The next thing I want you to notice is that there is a restriction here. We are restricted between 0 and pi. So I will show you what that looks like on your unit circle here in just a moment. Okay, so the first thing I'm going to do is algebraically change this. So I have 5 tangent t on the left, 3 tangent t minus 2 on the right. I'm going to treat this just like I would if I had 5x equals 3x minus 2. I'm going to subtract 3 tangent t from both sides. So that leaves me with 2 tangent t equals negative 2. And then what I'm going to do is divide both sides by 2 because remember I have to isolate the trig term. So I then have tangent 2 equals negative 1. Very good. Always keep in mind when you're solving these equations, once you've isolated your trigonometric term on one side, the value on the right, the value on the other side, depending on which side it is, the value on the other side of the equation has to occur on the unit circle. In other words, if you're dealing with sine or cosine, it has to be one of the values in the ordered pairs. If it's tangent or cotangent, it has to be a value you can find using your quotient identities from the unit circle. Okay, so tangent t equals negative 1. This one's pretty easy. Remember that tangent is going to be equal to negative 1 right here and right here, because when I divide sine by cosine, one of them needs to be positive, one negative, and they have to be the same value otherwise to get the negative 1. So what I have to do is I have to recognize the fact that I'm writing my answer in radians. So the value tangent t equals negative 1 is occurring at 3 pi over 4. Remember, since these are right across from each other, okay, you have to pay attention to that. Also, though, I have a restriction. So remember, we're restricted between 0 and pi right here. So this value I don't care about. I only care about the value in my restriction. And since I'm restricted between 0 and pi, I only care about 3 pi over 4. So that means that this t is equal to 3 pi over 4 radians. Okay? So that's all you have to write. You are done with that one. Okay, so now we're going to visit the next problem. So let's look at number 5. So again, notice some things. We're going to put our answer in radians. And by the way, if you're not told that and you have a restriction, notice that if pi's in your restriction, that's an indication we're dealing with radians, just like when we were graphing our trigonometric functions. All right, so this one, of course, 2 sine squared u, that is not just sine u on the left there, so I do have to do some algebraic manipulation. So I am going to begin by dividing both sides by 2. So I end up with sine squared u equals 1/2. And then, of course, since it's squared, I'm going to need to take the square root of this. So when I take the square root of sine squared u, I get sine u. And remember, when you take the square root, it's plus or minus the square root. So it's plus or minus the square root of 1/2. So we're going to have to rewrite this because that doesn't occur on the unit circle. So let's see what this means. The square root of 1 is 1. but the square root of 2 doesn't have, it's a decimal. So I'm going to have to rationalize my denominator here. And this gives me plus or minus radical 2 over 2. See, this value is familiar. It occurs on the unit circle. That's why I had to manipulate it. Okay, so let's look at our restriction here. Our restriction is one revolution of the circle, so the whole circle. So I don't have to account for adding a value to my solutions, I just have to see where my solutions occur. So notice that sine u is equal to plus and minus radical 2 over 2. So sine is positive radical 2 over 2 right here. It's negative radical 2 over 2 right here, and right here, and of course positive radical 2 over 2 right here. So there are 4 solutions to this problem. U is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 radians. Easy peasy lemon squeezy. Okay, notice because of this restriction only once around the unit circle, I did not have to add a value to it. Okay, I only have to do that when I'm accounting for all of the possible solutions. Okay, let's look at number 6. Again, I have to manipulate this algebraically, and it is restricted to once around the unit circle. So let me erase this stuff. Okay, so I've got 2 sine squared x equals sine x. The easiest thing to do here is going to be to divide both sides by sine x, because then I end up with 2 sine x equals 1. And then I have to divide both sides by 2. Excellent. So sine x is positive 1/2. That is occurring right here and right here. So since I'm restricted to once around the circle, those 2 solutions are my answers. So, and I've been told to write the answers in radians. So pi over 6 and 5 pi over 6 radians. Easy peasy. All right, now let's look at my next one. I'm going to have to do quite a bit of manipulation to this one. I want you to notice that there are no restrictions on this problem. You have not been given any restrictions. That means you're finding all solutions. That's going to change things. So first, let's isolate cosine x on one side. So I'm going to subtract 1 from both sides. Then divide by 4. And I want cosine x, not cosine squared x, so I have to take the square root. So when I take the square root of cosine squared x, I get cosine x. And then I have to take plus or minus the square root of 1 over 4. So what I end up with here is that cosine is equal to plus and minus, the square root of 1 is 1, the square root of 4 is 2. This is good because I know that this value occurs on the unit circle. All right, so I have to look at a couple of things now. Cosine x equals plus and minus 1/2. Where's that occurring? Well, it's occurring right here, right here, right here, and right here. But I have to account for all rotations of a whole circle. And remember, it's in radians. So x is equal to pi over 3 plus every possible rotation of the circle. So 2 pi n, remember n is an integer. That means it can be positive or negative. X is also equal to 2 pi over 3. All solutions, remember, so the rotation, 4 pi over 3. And 5 pi over 3. And of course, this is all radians. I don't think I did that on the last video, but Those are your solutions. So see, having restrictions versus not having restrictions, that's how that's going to look.